introduce the class 1 and class 2 capacitor for the power application. And in this table, we try to list down the capacitors requirement for the different applications. As you can see here, the capacitor density, the capacitance spectrality versus temperature and voltage, lower ESR, lower inductance, and so on. And for the application in wide band gap DC link and snubber or LLC resonant circuit, wireless charging systems. And for those characteristics, they are critical. We highlight in green. And for those characteristics, they are important but not critical. We highlight in yellow. So as you can see from this table, the class 1 capacitor, they can fulfill most of the critical characteristics, except the capacitance density here. So that's why to overcome the downside of the relative lower capacitance density, we recommend to use a relatively higher dice constant U2J products, and also using the Lidis stack. I would describe this in more detail later. But even the U2J dielectric, if we compare with the conventional S7R, the class 2 capacitors, the capacitance and dice constant is much lower than the class 2. This plot shows the typical temperature coefficient of the class 1, the COG in green, and U2J in blue, and S7R in purple. As already mentioned, we developed the dielectric is titanium dope calcium zirconate dielectric that has a relatively higher dice constant than the COG, but if compared with S7R, the dice constant is still much lower. And this plot shows the voltage dependence of the U2J dielectric. Even the curve here looks pretty sharp, but actually the capacitance drop versus the voltage applied is not that big. It's only 0.5% at 50 volt. And the right-hand side shows the microstructures with the nickel inner electrode and the grain size around 1 micrometer. And this is the our pattern process. We call the Lidis stack capacitors. We developed a copper tin. The TLPS stands for transient liquid phase sintering. The copper tin TLPS interconnect it melts at relative high temperature, around 400 degrees Celsius. And it can be used to bond the MLCC, actually not only MLCC, but it's the SMD components. We can also use the conventional solder reflow process for the SAC 305 solder reflow profile. So it's pretty similar. Nothing should be changed. Just use the conventional SAC 305 reflow profile. And this is the interconnect, how it looks like. And as already explained, this material has a high melting point, about 400 degrees Celsius, but it needs only low processing temperatures. As already explained, we can use the conventional cooling furnace. And it interconnect to tin, gold, silver, and copper, and it's lead-free and no bridging issues because it won't flow out like the conventional solder test. And it also compatible with the so-called flex termination MLCC, we all call the soap terminations. This is another example. The U2J Lidis stack for the switch tank converter applications. And we have two orientation. we call the traditional one, is just the MLCC stack. And the other one we call the low power loss orientation. They just put it down this way. We call it the low loss orientations. So we compare, as you can see from this table, the number of MLCC as a single chip, 2 stack, 3 stack, and so on. And as you can see, that with the lower loss orientation, the final stack, we have a lower ESR. But of course, the solder pad area is a bit higher than the conventional stack. This is the real thermal image. As you can see from this thermal image, compare these two orientation. Conventional one, the top surface temperature can reach 65 degrees Celsius. And for the low loss orientation, the top surface, the temperature is only 35 degrees Celsius. So it's a big difference. And we also compare the ESR, ESO, and self-resonant frequency of these two orientations. And again, the low loss orientation has lower ESR, lower inductance, and also a higher resonant frequency. We also monitor the aging effect till 2000 hours. So we didn't see any failure or significant degradation in terms of the capacitance and IR even after 2000 hours aging.